Hello friends, welcome to my channel. Today I am going to tell you about Joule-Thomson coefficient. It's Joule-Thomson effect or Joule-Thomson expansion. It describes the temperature change of real gas or liquid with respect to pressure when it is throttled or forced through a valve or a porous plug, or if it is passes through a porous plug. When it kept insulated, it means no heat is going out or no heat is coming in. Throttling process examples are refrigerator, heat pump, AC, air conditioner. Here I will show you the graph of vapor compression refrigerating system. It's pH chart, pressure versus enthalpy. One, two, compression, then condensation, then throttling, 3 to 4, 4 to 1 evaporator. Here our process is 3 to 4, throttling process. Here Joule-Thomson expansion, that experiment, here only 3 to 4, throttling process. This graph also very important. No change in enthalpy. H equal constant. Here Joule-Thomson coefficient is denoted as mu J/T or simply mu. Its graph, its temperature versus pressure curve, change of temperature with respect to pressure. Temperature T, here pressure. This graph is very important. In IES, Isro, GATE it won't come, but IES and Isro it will come. So its graph is, this is inversion curve. These are constant enthalpy process. This is inversion curve. Here slope is 0. dt by dp constant equal to mu. Isoenthalpy, H is constant, H is constant, H is constant. Process start from 1, then it goes like this, 1 to 2. You can choose 2 anywhere, here also, here, like that it will come. This is inversion curve. Where mu equal to 0 or mu zt equal to 0. Here this question was asked in IES 95. The question was Joule-Thomson coefficient is defined as, then your option A, B, C, D, like that it will come. Its answer is dt by dp at constant enthalpy. H is enthalpy. Its graph is T versus temperature versus pressure graph. H is constant. So its answer is dt by dp, H constant. Next question was asked in IES 1995 and IES 2017. The given diagram shows the throttling process of pure substance. The ordinate and abscissa are respectively option A P and V, pressure and volume; B, enthalpy and entropy; C, temperature and entropy; D, pressure and enthalpy. The graph was given like this. Nothing was mentioned, x or y axis. Simply process they will give 1 to 2, direction 1 to 2. You have to choose from the options. It's pH chat, here pressure, here enthalpy. Pressure and enthalpy they won't give, only simply outline they give. You have to choose the option. Next question was asked in IES 1996. The Joule-Thomson coefficient is the option A dt by dp H of pressure temperature curve of real gas, B dt by ds volume of temperature versus entropy curve of real gas, C dH by ds T of HS curve enthalpy versus entropy curve of real gas, D dp by dt P of pressure versus volume curve of real gas. It's dt by dp h at constant enthalpy of real gas. A is the answer. Next question, same question was asked as previous in 95 and 2017 also it was asked. The graph was given like this. You have to choose the ordinate and abscissa. Here saturated, liquid, only graph is little bit different. There it was given in as process 1 to 2, here like this. You have to choose the ordinate and abscissa. Question was, the saturated liquid and vapor region of a pure substance represent this graph, and you have to choose the ordinate and abscissa. Option A, B, C, D. Temperature and pressure, enthalpy and entropy, pressure and volume, pressure and enthalpy. It's pH graph. We know throttling process, pH graph. The graph is like this, it will come like this. BCRS process. This question was asked in IS 1999. Joule-Thomson coefficient is the ratio of a pressure change to temperature change occurring when a gas undergoes the process of adiabatic throttling. A, B, C, D like this given. B, temperature change to pressure change occurring when a gas undergoes the process of adiabatic throttling. It's mu Zt dt by dp at h. So its answer is B. Temperature change to pressure change occurring when a gas undergoes the process of adiabatic throttling. Adiabatic throttling means H is constant. H is constant. Next question was asked in IS 2001. In this question, 4 statements were given. You have to choose which statements are correct. First, availability is the maximum theoretical obtainable. It's correct. Clapeyron's equation is Vg minus Vf equal to dt by dp in bracket Hg minus Hf by Tg. It's Tp Vs dp by dt at constant V ds by dV at constant temperature. So if we take this dp and dt equal to ds is entropy, so it's Vg minus Vf it's Hg minus Hf by T, its entropy into here Bg minus Vf. So it's correct. 2 is correct. Next 3. A gas can have any temperature at a given pressure, unlike vapor which has a fixed temperature at a given pressure. This is also correct. Joule-Thomson coefficient is expressed as mu is equal to ds by dp at constant enthalpy. So It's wrong. Mu equal to dt by dp at constant enthalpy. So 4 option is wrong. Only 1, 2, 3 option A is correct. That Clausius-Capron equation again I will write. dp by dt here enthalpy by temperature into Vg minus Vf. That second option, it was correct. This question was asked in IS 2007. The throttling process of certain gases may be used for getting the refrigerating effect. It means cooling. The value of Joule-Thomson coefficient for such throttling process. Here again I will draw that curve. Temperature versus pressure curve. This is inversion curve. Enthalpy is constant. This region is cooling region. This region is heating region. Direction is like this. This is here mu equal to 0. This region mu is greater than 1. Here mu is less than 1. Mu is slope of the curve dt by dp. Right. So in this question it's asked for getting the refrigerating effect. So cooling region mu is greater than 1. D is the answer. This question was asked in IS 2007. When a real gas undergoes Joule-Thomson expansion, the temperature, option A, may remain constant, always increases, C, may increase or decrease, D, always decreases. I will show you the curve. Temperature versus pressure. This is inversion curve. Constant enthalpy. So direction is like this. In this region, heating region, here temperature increases, this region cooling region. So we are decreasing the pressure. From 1 we starts reducing the pressure. So option is C, may increase or decrease. If we stop here, its temperature increases from 1 to 2. If we stop here to dash, its temperature will decrease. So it may increases or decreases. This question was asked in IS 2009. In a throttling process, which one of the parameters remain constant? BCRS graph I will show you. Vapor compression refrigerating system. pH chart. One to 2, then 2 to 3, 3 to 4, 4 to 1. Here 3 to 4 is our throttling process. 1 to 2 compression, 2 to 3 condensation, 3 to 4 throttling, 4 to 1 evaporation. 3 to 4 is our throttling process. Here enthalpy is constant. Here H3 equal to H4. Both points enthalpy is constant. So our option is C. Next question was asked in IS 2001. List 1 and list type of two question. You have to match A. Compressibility factor, B. Joule-Thomson coefficient, C. Constant pressure specific heat, D. Isothermal compressibility. A. minus 1 by V dV by dt P, dP by dt constant pressure, 3. dt by dP constant enthalpy, 4. PV by RT. So compressibility factor A is 4, it's Z, A is 4, B. Joule-Thomson coefficient, it's 3, dt by dP, we know that graph, temperature versus pressure graph at constant enthalpy. So B is 3, constant pressure specific heat, C is 2, dP by dt, it's C, constant pressure specific heat, option is 2, C 2, dH by dt at constant pressure. Then D, isothermal compressibility, D is 1. Sometimes this type of question also asks. Joule-Thomson coefficient, you know. So Joule-Thomson coefficient is very important. You should remember the graph, temperature versus pressure, enthalpy is constant, and which side heating and which side cooling. There mu value greater than 1 or less than 1 or mu equal to 0. 3 values you have to remember. Cooling mu is greater than 1, heating mu is less than 1. And that pH curve, pressure versus enthalpy curve. So many times it was asked in IES, Isro, for other exam also. It's very important. So thank you friends for watching my video. If you like my video, then subscribe it.